So here we go. Day 2 of Chapter 7, Section 2, more radicals, simplifying radicals, doing more things with radicals. So what we've done so far, we've seen a radical, we've seen how it works and what it does. Today we're going to look more into how to simplify this. Now before we continue, go ahead and pause and make sure you have course pack page 706, course pack page 706, the list of the perfect squares, cubes, the fourths, the fifths, and the sixths, because we're going to be looking at some of these today, and I need to be able how to reduce them, and doing it in my head and using the sheet seems to make it a lot easier than trying to figure it out on my calculator. Whenever I have the square root of 40, what I want to do is I want to ask myself, what perfect square goes into 40? Well, I can factor 40 as the square root of 4 times the square root of 10. If I multiply that out, I still get square root of 40. But the square root of 4 is 2. Square root of 10 doesn't change, so 2 square root 10 is the simplified version of the square root of 40. All I did was simplify it by finding my perfect square and factoring that out. Now, again, if I couldn't remember that, I could look in my note sheet on the course pack page 706 to find that perfect square. Number 2, square root of 72. Again, I'm looking at, I'm looking on my course packet squares, perfect squares. If I look at the number 72, well, what are my factors of 72? My factors of 72 are 1 and 72, 2 and, if you think about it, 36, 3, and if you think about it, what is that, 24, 4, and what is that, 18? 4 and 18. 5 doesn't go into it. 6 and 12. 7 doesn't go into it. 8 and 9, and then 9 and 8. And so those are all my factors of 72. And so what I'm looking for in this problem is what factors out to be 72 but has a perfect square? Well, hopefully you notice fairly quickly that 36 is my perfect square. So I could then say, okay, so this is the square root of 36 times the square root of 2. Notice I put the perfect square first. The square root of 36 is 6. Square root of 2 is just the square root of 2, and I'm done. Well, what else could I have done? Well, if I looked at this, I could have realized that 4 was a perfect square. I could have realized that 9 was a perfect square. Could I have used either of those? Yes, but once I realized that 4 was a perfect square, I needed to realize that 18 was 2 times 9, and there's another perfect square. Or if I realized 9 was my perfect square, I needed to then see that the 8 was 2 times 4, and there's my other perfect square. I can reduce this several different ways. Regardless, it should simplify to 6 square root 2. And that's how I get my answer, my final answer. Let's look at the square root of 75. Again, what are my factors of 75? Well, it's 1 and 75. 2 doesn't work. 3 times 25. 4 doesn't work. 5 times 15. Correct? Yep. 5 times 15. 6. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 doesn't work. 11. Oh, well, that gets me back up to 15 and 5. That's my repeat. So I'm good. So my factors are 175, 325, 515. My perfect square is 25. So I write the perfect square, the square root of 25 times the square root of 3. So this is 5 square root 3. And that's my final answer. Again, I want to look for that perfect square. Okay, let's look at number 4. Now I want a cube root. Again, this is where my course pack page 706 comes in handy. My cube root, what's the cube root of 27? Well, 27 is a perfect cube, and so my answer is just 3, because 3 times 3 is 9, times 3 is 27. Okay? Okay, well, let's go on to number 5. The cube root of 10,000. Well, what perfect cube goes into 10,000? Well, I'm going to break up 10,000 into 1,000 times 10, because the cube root of 1,000 times the cube root of 10, well, the cube root of 1,000 is 10. So my answer is 10 cube root of 10. That's 810. Oh, that's an ugly 10. Let's rewrite that. So that's 10 cube root of 10. Again, an ugly 10. I'm good with ugly 10s today. Why? Because 10,000 has a perfect cube. That perfect cube is 1,000. The cube root of that is 10. Did you notice that every time I'm doing a cube root, I'm finding the largest cube root? Again, if I look at the cube root of 10,000, I can find an 8 in there. I can probably find a 125 in there. But my largest is 1,000, so that's the one I want to factor out. That's what makes things the easiest. So let me get rid of this so that I can do my number 6. Okay. Number 6, I want the cube root of 16. What perfect cube goes into 16? Well, again, my factors of 16 are 1 and 16. 2 and 8. 3 doesn't work. 4 and 4. There's my repetition. I can stop. My perfect cube is 8. So I can write this as the cube root of 8 times the cube root of 2. The cube root of 8 becomes just 2, because 2 times 2 times 2 is 8. And the cube root of 2 stays the cube root of 2. There's my simplified answer. So here we go, number 7. Again, the fourth root of 64. The fourth root of 64. If I look on my perfect numbers, my course pack page 706, my fourth root, my perfect things to the fourth power are 1, 16, 81, 256, and 225. 1 and 16 are the only ones that are less than 64, so hopefully 16 will be in there. It's 1 and 64, 2 and 32, 3 doesn't work, 4 times 16, 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 times 8 is 64. There's my repetition. I can stop. My perfect cube, again, is 16. So I like to, it's not a perfect cube, it's my perfect fourth to the fourth power. So I want the fourth root of 16 times the fourth root of 4. The fourth root of 16 is 4. That's a lie. The fourth root of 16 is not 4. The fourth root of 16 is 2. The fourth root of 4 stays the fourth root of 4, because that's not a whole number. And there's my answer. Now, what if you had said, but wait, I'm a smart little guy. I can look over there and I can see that the fourth root of 64 is actually equal to the fourth root of 2 to the 6th, because looking on course pack page 706, 2 to the 6th is 64. Well, being the smart little guy that we are, we can say, okay, that's the fourth root of 2 to the 4th times the fourth root of 2 to the 2nd. The fourth root and the fourth power cancel, leaving just 2. 2 to the 2nd is 4, so I have 2 fourth root of 4. I still end up with the same answer, whichever way I choose to do it, regardless of the way that I choose to do it. All right, so let's continue. Multiply and simplify these radicals. So the first thing I want to do is I want to look at this and I want to say, okay, There's different ways of doing this. I can say, well, square root of 8 times square root of 5. Well, that's the square root of 40. What perfect square goes into 40? Well, that's the square root of 4 times the square root of 10. So that's 2 square root 10. 8 times 5 is 40. What perfect square goes into 40? 4. So that's 4 times 10. Square root of 4 is 2. 2 square root 10 is my final answer. Is that the only way of doing it? No. I could look at this and say, hey, what perfect square goes into 8? Well, that's the square root of 4 times the square root of 2, and I still have the square root of 5. Square root of 4 is 2. Square root of 2 times square root of 5 is the square root of 10, and I still end up with the same answer. Do I care which way you do it? No, just what makes sense for you. However, look at number 2. There's no perfect square that's in 2. There's no perfect square that's in 6. So I'm going to multiply and get the square root of 12. Then I need to think, well, 12 has factors of 1 and 12, 2 and 6, 3 and 4. 4 is a perfect square. So I can say square root 4 times square root 3. So this is 2 square root 3 is my final answer. Again, I'm trying to find a perfect square. If I can pull it out first, like I did here in number 1, that works. If I can't find it until after I multiply like I did in number 2, that works as well. I just need to show how to find that perfect cube. Excuse me, that perfect square. I need to factor it out. Number 3 and 4 are looking at perfect cubes. Again, I could multiply this out and get the cube root of 81. And then I could reduce that out. But I could I could save myself some trouble and realize that the cube root of 27 already is a perfect cube. That's 3 times the cube root of 3. So I'm just going to switch their order, and my answer is a 3 cube root of 3. And that's it. I'm done. I always want my whole number in front of my root, in front of my radical sign. And lastly, number 4 here, not of this page, lastly. Is there a perfect cube that goes into 12? My factors are up here. We had 1 and 12, 2 and 6, 3 and 4. None of those are perfect cubes. So let's go ahead and multiply this out. 2 times 12. This is the cube root of 24. Well, what perfect cubes go into 24? Well, let's see. 24, my roots are 1 and 24, 2 and 12, 3 times 8, 4 times 6, 5 doesn't work, 5, but then 6 times 4 is a repeat, so I have them, and I need to realize that 8 is a perfect cube. So I can rewrite the cube root of 24 as the cube root of 8 times the cube root of 3. The cube root of 8 is 2, cube root of 3, and there is my answer. All I'm doing here is simplifying, simplifying, simplifying. All right, well, what else can I do? Well, let's add and subtract, and then let's see if we can simplify, or maybe we have to simplify first. Let's see, look at number 1. Square root 5 plus 3 square root 5. Well, remember in front of this square root 5, there's my lovely number 1. My roots, it's the same power. They're both squared. And the radicand, what's in the radical, is the same. So square root 5 is the same as square root 5. So 1 square root 5 plus 3 square root 5 is simply 4 square root 5. That's how I add. Number 2, I'm going to do the same thing, but I'm going to subtract. My square root 6 and square root 6 are the same, so 5 square root 6 minus 6 square root 6 is 3 square root 6. What's in the radical doesn't change, but they have to be identical to add or subtract. Let's look at number 3, talking about needing to be identical. In number 3, they're not identical. I have square root 8, square root 2. Can I reduce the square root of 8 to match the square root of 2? Well, the square root of 8 is square root 4 times square root 2. The square root of 4 is 2 square root 2. And I still have this plus 10 square root 2 plus 10 square root 2. Now, when I simplified square root of 8, my square roots are the same, square root 2 square root 2. 2 square root 2 plus 2 square root 2 plus 10 square root 2 is 12 square root of 2. And there's my answer. So let's go on to number 4. Number 4, can I reduce this? Well, let's see. I have the square root of 40 and square root of 160. Those obviously are not the same square root. So what perfect square goes into 40? Well, that's square root 4 times square root 10. I have this 3 in front. Square root of 4, 2. So 3 times 2, square root 10. So this is 6 square root of 10. Now let's do the second part. Over here, I have the square root of 160. Yes, 4 goes into 160, but remember, I want to try to pull out my largest square root. My 5 stays the same. Then I have the square root of 16, which is my largest square root, times the square root of 10. There is my matching root. That's what I personally was shooting for, to see if I could find a 10, and I did. So the square root of 16 is 4 square root 10. 4 times 5 is 20 square root 10. So now I have the same square root. Square root 10, square root 10. This is addition in the middle, excuse me. 6 square root 10 plus 20 square root 10 is 26 square root 10. That's how I find my answer. I have to make my roots, my square roots or cube roots or whatever they are, identical. Talking of which, on questions 5 and 6, I'm now using cube. That's not what I want. I'm now using cube roots. So on number 5, I have the cube root of 16. Well, what perfect cube goes into 16? The 6 in front stays there. Well, that's the cube root of 8 times the cube root of 2. Can I make the cube root of 32 match the cube root of 16? Excuse me, can I take this cube root of 32 down to a cube root of 2 so that I can add these? Well, let's find out. So this is subtraction 2. What cube root goes into 32? Well, let's look at 32. 32, my factors are 1 and 32, 2 and 16, 3 and 8, 4 and okay, 3 and 8 is wrong. Sorry. 3 doesn't go in the 32. It's 4 times 8 is 32. Those are my roots. My perfect cube is 8. So I can write this as minus 2 times the cube root of 8 times the cube root of 4, because that's my other factor. So what's my next line looks like? Well, the cube root of 8 here is 2, so 6 times 2, cube root of 2, minus 2. Cube root of 8 is 2, so times 2, cube root of 4. 6 times 2 is 12, cube root of 2, minus 2 times 2 is 4, cube root of 4, and I have a problem. My roots don't match. This is a cube root of 2. This is a cube root of 4. I can't combine those. This is my final answer. It's totally simplified. As much as I can do, my roots are not the same, so I cannot add them. I'm done. Let's look at number 6. In question number 6, the cube root of 250. My goodness, what cube root goes into 250? So I pull out my course pack page 706 and I'm looking at my cube roots. 125. Hey, what do you know? Because I need to recall, I'll do it over here. 250 is 125 times 2. Yes, I could have listed all my factors, and if in class I can show you in a way how to do that on the calculator, but you have to ask me. If you don't ask me, I'm not going to show you, because this is one of those things for the people who don't watch the videos. I want you to ask me to do this. So up here I have the cube root of 125 times the cube root of 2 minus. So now I need to find the cube root that goes into 128. So I'm looking at 128. I look at my cube roots. 125 is a cube root, but that doesn't divide into 128 evenly. 64 is a cube root, and that does divide into 128 even. So 128 is 2 times 64. So this is going to be the cube root of 64 times the cube root of 2. Well, that's kind of nice because I already see that I have the same cube root on these. I have the cube root of 2 and the cube root of 2. So let's simplify. The cube root of 125 off of course page 706 is 5 cube root of 2. Minus the cube root of 64 is 4 cube root of 2. 5 cube root of 2 minus 4 cube root of 2 gives me my final answer of 1 cube root of 2, but I don't have to write that 1, so I'm just going to write the cube root of 2. Those are my problems. We're at 21 minutes in. I've got a couple more pages. Actually, I have one more page. I'll do 3 examples off this page, even though I have 5 problems. Divide and simplify these radicals. Division is probably one of the most odd and weird things that we're going to do when it comes to radicals. We need to remember that whenever I divide by a radical, I have to rationalize my denominator. What does that mean? I don't want a square root in my denominator. So how do I get rid of that square root? Well, I have to multiply by something that's going to make it a whole number. Square root of 3 times square root of 3 is square root of 9, which is 3. Well, I can't just multiply the denominator by square root of 3 because that's changing my problem. So whatever I do to the denominator, I do to the numerator, the top. Square root of 3 divided by square root of 3 is 1. I'm multiplying by 1, and that doesn't change anything. My numerator becomes 4 square root 3, and I just carry that over. And so my final answer is 4 square root 3 over 3. I rationalize my denominator by getting rid of that square root of 3 in the denominator. All right, so let's try number 2. What's different with number 2? Well, number 2, I no longer am dealing with square roots. I now have a cube root in my denominator. So what am I going to multiply by to get a whole number? If I tried the cube root of 2, I would get the cube root of 4. 4 is not a perfect cube. That doesn't work, so I'm going to erase and back up. What number can I multiply by, not to get a square root, but to get a cube root? Well, the cube root, if I multiply by the cube root of 4, I get the cube root of 8. And the cube root of 8 is 2. So this is where things get a little hairy, a little different than what we're used to. I can't multiply by the exact same thing because here I have a 2, here's a 4. I have to multiply by a number that's going to give me a perfect cube. 2 times 4 is 8. 8's my perfect cube. So I have to realize that this is 2 to the first power. This is 2 to the second power. When I multiply them, I get 2 to the third power, which is what I can take the cube root of. So in here, I had to put 2 to the second power so that I can get 2 to my third power to take the cube root of. So after all that explanation, I'm going to pull the red stuff away. I can keep those lines. And I'm going to continue because now I can say the cube root of 4. So this is 6 cube root of 4. So this is 6 cube root of 4 over 2. But I can reduce 6 cube root of 4 over 2 because 6 divided by 2 is 3 cube root of 4. Once it's a whole number, I can go ahead and reduce that 6 and that 2 to get my 3 and my final answer. Let's try number 3 one more time. And this is the last example I'm going to do. If you need more, you can ask me in class. But let's see what I have here. I'm going to multiply here. And here I have a couple options. I want to get rid of my denominator. I want to get that cube root out of my denominator. And I could either, since this is a 9 to the 1, I can put it over here 9 squared. So that 9 to the first times 9 to the second is 9 to the third. And I could get 9 to the third over here. But in my opinion, that's a really big number. And that's a lot more than what I want to deal with. What I would rather do is realize that 9 is 3 squared. That means I need to multiply by 3 to the first to get 3 to the third so I can do the cube root. So in here, I'm going to do the cube root of 3 so that I end up with the cube root of 27, which reduces to 3. Could I have done cube root of 9 times cube root of 81? So I get the cube root of, no, I don't have this memorized yet. My apologies. But the cube root of 9 is 729, so that I could have cube root of 729, which is 9. Could I have done that? Yes. Is it easier, in my opinion, to notice that 9 is already a square and I don't have to multiply by such a big number and just do 3 to the first to get 3 to the third? I think that's a lot easier. Ignore that, Bell. The other one would have worked. So I now want to do up here the cube root of 3 because these two have to be identical. This is 3 cube root of 3. I already have 3 in my denominator, and this is 3 cube root of 3. The 3's cancel, and so my final answer is the cube root of 3. Again, we can spend more time on this in class. If you have questions, please ask me questions. That's my final answer, the cube root of 3. I'll see you tomorrow.